Hello, class. Okay, so we're going to talk about this vibrating string here. And I have it set up, well, you can see the string. Let me describe what's happening. Over on this end, we have the string hooked up to this mechanical vibrator. Let me turn this on. Right now, you're not going to see much happening. You can hear it. This is at, sorry, you can't see a number. It's at 1 kilohertz. So this is oscillating very quickly. Yeah, if I touch it, I can feel it. But because it's going so fast, it is very low amplitude. I'm going to turn the frequency down to basically 0. It's going to make some cool sounds on the way down. Let's get it down to 0. Okay. So now, if you look at this end, the box is kind of in the way. Let me just hold the camera up and then I'll put it back. Get a closer view of this. You can actually see the device. So like this end of the string, you can see it moving up and down very slowly because it's set for a low frequency. Now on the other end, we have a pulley. There's mass attached to the other end. So there's tension in the string equal to the weight. And so now let's set this back up so we can see the overall string. Yeah, we can actually get the whole string here. I was facing this so you could see the frequency. I don't think it's visible, but that's fine. I can just tell you what the frequency is. Like right now it's 0.3 hertz. And let's increase it so it's moving. And here's good. Let's look at the string here. This is at 2.9 hertz. And what we have is basically randomness. This is called noise. There's nothing really going on that's interesting. Basically, the string, if you focus on one point, it's moving up and down, but it's doing so randomly. If you look at it later, it's going to have a different amplitude. Let's keep increasing the frequency. See what happens. Now we're getting some interesting behavior. Look at what happened to the amplitude here. I'm going to make some fine adjustments. So yeah, we've increased it. The amplitude shoots up. Now we have a very large amplitude. And then I made a slight adjustment and it dropped practically to 0. So it's at 7.6 hertz, 7.7. 7.9, that looks like about the biggest amplitude motion here. And yeah, I guess it's kind of visible. So you can see this very large amplitude motion. And what's more, this is our first standing wave pattern. This is the resonance frequency. Like if you look at, we basically have nodes at either end. This end's moving up and down a little bit, but not enough to really worry about. And we have an antinode in the middle. And if you just pick a random spot, I don't know if this is going to be a good way to demonstrate that, but like here, if you look at the top and bottom of the, it's moving up and down, but if you just look at this reference line here, the amplitude of that point looks like it's about the same. That's why it's a standing wave pattern. Any point is moving up and down, but it's not changing with time. So that occurs at very particular frequency, like here, 7.9. Now, what happens if we increase the frequency? Let's go to 8.4. We're back to noise. This is actually a really good frequency to look at because it looks like we get some large amplitude motion and then it just drops to 0. So there's waves that are just bouncing around on this string. There's energy being provided by this oscillator on the end. That's being powered, that's supplying energy. And there's energy being dissipated by the string in terms of like friction, or when the wave hits the end at that pulley, or at the other end, it can cause vibrations, which dissipate some energy. And so it reaches a point where energy is entering the string just as quickly as it's leaving. But overall, we're getting noise. There's waves just bouncing around, interfering with each other, but they're not doing so in a very predictable or repeating fashion. Now, 7.9, let's go back to that. This is a fundamental frequency, or the first harmonic. Now, remember from lecture, the second harmonic for this particular system, depends on what you're talking about, but for a string with two nodes at the end, the next standing wave pattern should be double the frequency. So we should expect around 15.8 hertz to get the next resonance pattern. And what we should expect is one additional node. So here we have two nodes, one at each end. When we go up to 15.8 hertz, we should expect another standing wave pattern with nodes at the end and one right in the middle. So let's see if that's what happens. Oh, I went the wrong way. So yeah, we're back to noise. We're around 8. Here's 9 hertz. Amplitude is massively decreased and irregular. We get different kind of noise. We're at 10 hertz, 11, 12, 13, 14. We're getting close. And the pattern looks about right. We have a node in the middle. Let's see if we can increase the amplitude. Oh, there we go. So I'm at 15.7, and that looks pretty good. So we have a node in the middle, and node at each end. So now there's 2 antinodes in the string. And, okay. Now, the fundamental frequency was at 7.9. So the third harmonic should just be 3 times that frequency. So we'll have 23.7 should be the next. So we're at 15.7. Let's go higher. So yeah, we lose our standing wave pattern, or it kind of is still there, but the amplitude is decreased. 17. It was 7.9, so it should be 23.7 should be the next. So we're at 19. Here's 20, 21, 22. Here's 23 hertz. Let's go up to that 0.7 and see the amplitude. That's 0.9. Here's 23.7, and again, we have our, it's still not perfect. I gotta find the right frequency that, kind of gives us maximum amplitude. That's when resonance occurs. Or that's a consequence of resonance. So yeah, I think 23.9 is pretty good. So now we have 2 nodes in the middle. So like every time we go to the next standing wave pattern, we'll get another node. Here's if we can zoom in on this a little bit. You can get a closer look. I think I zoomed in too much. Let's go right in the middle. I want to be able to see, like, yeah, so like 2 nodes and antinode in the middle of that. Let's do one more standing, or at least one more. So the next one should be occur at 31.6 hertz. I'm going to go quickly there. We're at 26 hertz, 27, 28, 29, 30. We should be getting close. And we kind of have our standing wave pattern. The amplitude is not so high. Here's 31 hertz. Here we go. 31.6. It's a little bit off. We can go to point. I want to get it back to a standing wave pattern. That's pretty good, actually, right there. This is 32.1. And, sorry, see how it looks on the camera. Yeah, you can definitely see when you're in a standing wave pattern. And let's go back to this far view so we can count the nodes. It's kind of hard to see. We've got that white board. I should have put a screen in the background. Kind of block that off. Or just done it so there's a wall behind it. But we've got the nodes at the end. So we've got one here, a node here, and a node here. So a total of 5 nodes. Let's get up to another standing wave pattern. It should be around 39 hertz or so. So it's at 36, 37. So it looks like a standing wave pattern. We just have to get the amplitude right. There, we've got our big amplitude. It's hard to get it exactly right. That's pretty good. That was. There's like 1, 2, 3, 4 nodes in the middle. And yeah, that looks like a good pattern. Let's go up higher. So 47 around there maybe would be the next one. Here, so we're at 40, 41, 42, 43. Look how low the amplitude is there. 44, 45, 46. That's not too bad. That's about 46.7. So yeah, I'm just going to count the nodes. 1, 2, 3, 4. There's a total of 7 nodes, including the 2 endpoints. And so it's not perfectly tuned into the right frequency, but very close to it. Where you get these, sequence of node, antinode, node, antinode. And let's kind of zoom in a little bit. I picked the worst location to do this because of the background. The walls and the whiteboard are not ideal. But see how close we can zoom in on one of these patterns. Okay, so again, these are all different resonances. I think I'll do one more just for fun. Around 55 hertz should give us another one. So there's 47, 48, 49, 50, 51, 52, 53. Just waiting for that amplitude to go up. There's 54. 55, there we've got our amplitude. Just have to fine tune it. And again, so as the frequency increases, obviously the wavelength is decreasing. Because a wave on a string is constant. It depends on the tension and the density. And those are fixed in this demonstration. So yeah, if you increase the frequency, we can see the wavelength is decreasing and we get more nodes. Right now, I'm counting 8 nodes. So like every standing wave pattern just adds 1 node. I don't know how high we can go with this. Let's see. Oh, that's pretty good. That's more consistent. That's 54 hertz. So if we go up to around 62, we should have another one. So we're at 50. Oh, I'm going the wrong way, sorry. 55, 56, 57, 58, 59, 60, 61, and we should start getting it soon. We're at 62 hertz. I want to get more amplitude though. There we go. Yeah, the amplitude does decrease just because it's oscillating so quickly. It's harder to get it to like cycling so many times. It's hard to get this larger amplitude. So here I'm going to count the nodes. 1, 2, 3, 4, 5, 6, 7. No, I think there's 9. Let me just make sure. 1, 2, 3, 4, 5, 6, 7. Plus a 2 at the end. So we're at 9. Let's just see if we can get 10. So this is 63 hertz. Around 71 should be the next one. So 64, 65, 66, 67, 68, 69, 70. That's actually not bad right there. There's 10 nodes. And I'm going to see if I can just get more amplitude without. Yeah, I got a little more amplitude there. That kind of destabilizes it though. I think that's the best I can do right there as far as amplitude is concerned. That's at 71 hertz. Let's go to 80. I'm just going to do this quickly. So 77, 78. Oh wow. Let me try to get that pattern again. So very small wavelengths now. So I'm going to count the nodes. 1, 2, 3, 4, 5, 6, 7, 8, 9, plus a 2 at the end. So we have 11 nodes here. Yeah, you can see how consistent this pattern is. So there's waves bouncing around, but they're timed just right, you know, at this frequency to give a resonance pattern. Okay, that's 77 hertz. Let's go up to 85. And maybe stop there before things get too crazy. So there's 80, 82, 83. Okay, looks like we've got a pattern. I want to get the amplitude up a little. Okay, so kind of lost it a little. Yeah, I think this might be the end of the road. Okay, that looks stable. I'm going to count the nodes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 12 nodes. Can't resist. We'll go up one more to about 94 hertz. There's 88, 89, 90. So the wavelength keeps decreasing, and it might even be hard to, you know, if they get too close together. This is 94 hertz. That actually looks pretty good. I'll count the nodes on this one. 3, 4, 5, 6, 7, 8, 9, 10, 11. So yeah, we're up to 13 nodes. We started with 2, now we're up to 13. And yeah, with the wavelength getting smaller, yeah, it's going to get harder to maintain this. I'm going to quickly go up to 102 hertz. Yeah, we've got another node. Let's go up to 110. 110. Yeah, that's a nice standing wave pattern. I can't see the camera now, but let's see what it looks like here. Yeah. And again, you can't see the whole thing. If I bring it back, yeah, it's just the background is not ideal. Yeah, you can see the background. I was doing that torque demonstration, trying to get everything done today. Yeah, you can't really see it here. If this pandemic doesn't end, I'll probably just do this with a screen so you can see it better, like the whole pattern. Since it's set up, I'm going to see how high I can get this going. So 118 should be the next one. Yeah, we're at 118 now. to get it a nice pattern and with a good amplitude. It's actually about 119. I want to see how many nodes I can actually get out of this thing. I'm going to count them now. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Plus the 2 at the end, we're at 117. Or, sorry, 126 hertz, but 17 nodes. Yeah, basically I'm increasing by about 8 hertz every time. And that gets us, this pattern is very consistent. Yeah, it's hard when the nodes get too close together, it's hard to really tell what's going on in between. We don't get the big amplitude anymore. Cool though. And yeah, it's hard to even distinguish a node from an antinode at this point. So I think we'll stop this soon unless we can get some better amplitude out of it, but I'm gonna just crank it up. Yeah, like it almost looks like it actually is a wave pattern here, but the difference between an antinode and a node is so small, it's kind of hard to see. Look at what it says on the camera. Yeah, you can't really see it on the camera. I can kind of see nodes and antinodes. I think we'll stop it here. And yeah, so it's a good just demonstration. Okay, turning it off. So just a demonstration of resonance and standing waves. So that'll be it for that one.